Alright, back with another proof, this time the cosine rule. Again here I've just got the standard scalene triangle, could be anything, and I'm going to start by drawing in the height. Now I mentioned during the first video that the cosine rule is really just an extension of Pythagoras' theorem. So let's go ahead and write Pythagoras' theorem for the two triangles that I've got there. Now I can't do that just yet because this length B goes all the way across. So I'm going to call this part of it on the left hand side there X, which would make the other part of it there B minus X. Now let's go ahead and use Pythagoras' theorem on each of those. So on the left hand triangle I'm going to get C squared equals X squared plus H squared. And for the other triangle the hypotenuse is A, so I've got A squared equals H squared plus B minus X all squared. Get them, you can see they've both got an H squared term, so I'm just going to write them in terms of H squared. So on the left here I subtract X squared from each side, so I've got C squared take X squared equals H squared. Then on the right hand side I've got to subtract B minus X all squared. That's equal to H squared. You can see I've got two expressions equal to H squared, so the two left hand portions must be equal to each other. So I've got C squared take X squared equals A squared minus B minus X all squared. Well, the left hand side I can't do a lot with just at the minute. The right hand side I can expand. Hopefully you remember how to do your expansions. You can do that the long way if you like. Plus X squared. We're going to do that next chapter anyway, but most of you will remember that. So just expanding now that negative in front of the bracket. So I'm going to have negative B squared. Negative by a negative gives me positive 2bx, and negative by a positive minus x squared. Conveniently, negative x squared on each side, so I can cancel those terms. So I've got something that's approaching the right expression, but it's not quite there yet. Get my black pen back. Yeah, and that got it. What I'm going to do, this is a negative, I want to get that on the other side, and the 2bc cosine, that should be on the other side too. So what have I got? I'm going to add b squared, so I'm going to have b squared plus c squared. I'm going to subtract 2bx from each side. Minus 2bx equals a squared. Now we've pretty much got our rule there. You'll remember the rule is a squared equals b squared plus c squared minus 2bc cosine a. You can see the c cosine a is what I'm missing instead of x. Let's go back and look at that triangle on the left up here. What would the cosine of A be equal to? Well, for this triangle here, the cosine of A would be the adjacent side, which is x, divided by the hypotenuse, which is c, multiplying through by c. I've got c multiplied by cosine of A equals x. So I make that substitution back down here. I get b squared plus c squared minus 2bc cosine A, and that's a squared. And there we have our cosine rule. Obviously if I started with another side I could rearrange the letters, but the rule still holds. Hope that was valuable for you. See you next time. Cheers.